What is climate change? Climate change is believed to be the consequence of unchecked pollution. Human activity in the last 100 years has influenced the release of carbon emissions over the years, especially in the last 50 years, which has caused effects on the environment and planet Earth. The burning of fossil fuels is the main influence for the releases of carbon emissions and/or other emissions such as methane and nitrous oxide that can contribute to global warming. With large amounts of carbon dioxide being burnt off, this creates excess carbon, which is then trapped in the Earth's atmosphere. The trapped carbon subsequently heats up, altering the Earth's climate patterns.
The causes of climate change are severe. We are seeing increases in ocean and atmospheric temperatures, resulting in the melting of snow and ice, causing a rise in global sea levels. With extra heat in the atmosphere and oceans, this can cause detrimental effects with changes in ocean circulation and patterns, which can influence changes in the weather alterations, such as more frequent storms and heavy rainfall. It can also lead to droughts and less rainfall in some areas around the world, including Australia.
With the beginning of the industrialisation in the second half of the 18th century, humans started to steadily increase the amount of greenhouse gases, such as CO2, methane and nitrous oxide in the atmosphere, due to the combustion of fossil fuels, cement manufacturing, and the intensification of agriculture and deforestation. As a consequence, mankind began to interfere with the climate system of our planet in a dangerous manner.
When carbon dioxide dissolves in the ocean, carbonic acid is formed. This leads to high acidity, mainly near the surface, which has been proven to inhibit shell growth in marine animals and is suspected as a cause of reproductive disorders in some fish. Unless we are able to control and eventually eliminate our fossil fuel emissions, ocean organisms will find themselves under increasing pressure to adapt to their habitats' changing chemistry or perish.
For tens of millions of years, Earth's oceans have maintained a relatively stable acidity level. It's within this environment that the rich and varied web of life in today's seas has arisen and flourished. But research shows that this ancient balance is being undone by a recent and rapid drop in surface pH that could have devastating global consequences.
With the climate change having such a detrimental effect on the environment, numerous Earth systems are going into disarray, namely the biodiversity of ecosystems. Land clearing along with human inhabitants and climate change are seen to be a major issue for Australia.
With Western Australia having so few unique and exotic species evolved for the specific environment, making them vulnerable to the impacts of climate change. More than 60 endemic vertebrates are found in regions in Western Australia that could possibly be at risk. Bird migration is one of the many factors that are currently being affected by climate change, with heat waves being said to be the major influence for birds' disrupted migration patterns.
In a society accustomed to dominating or improving nature, we need to finally accept the mistakes of our past, illusions of a primitive species, and determine not what we can extract from nature, but what we can learn from her. Nature is a masterpiece. Doing it nature's way has the potential to change the way we grow food, make materials, harness energy, heal ourselves, and store information and conduct business.
There are already numerous products being used and developed in which we have mimicked nature's designs with promising results. The Eastgate Shopping Centre in Zimbabwe has boasted architectural genius. Based on the design of a termite's nest, using only 10% of the energy of a typical building its size. Not only this, an American company has designed a cement that extracts CO2 from the atmosphere as it sets. New thin solar cells based on the photosynthesis processes, the ability to harness wave energy like that of large kelp, beetle-inspired fog harvesters, as well as water purifiers designed from an animal cell's aquaporins. The opportunities are endless.
Research is discovering what works in the natural world and, more importantly, what lasts. After 3.8 billion years of research and development, failures are fossils, and what surrounds us is the secret to survival. The more our world looks and functions like the natural world, the more we are likely to be accepted on this home that is ours, but not ours alone.
With the forevermore expanding population and economic growth, the reality is that our climate suffers from this growth. If society does not decouple from the current environmental pressures of climate change, in the near future, the systems that support life on this planet are going to collapse. Decoupling is identified within 4 key points: regeneration, sustainability, assimilation, and avoiding irreversibility.
It has been proven when needed that action can be taken to combat climate change. The Montreal Protocol, substances that deplete the ozone layer, is one of the most successful and effective environmental treaties ever negotiated and implemented. Germany has also taken action, as it has reduced total annual sulphur emissions by nearly 5 million tonnes within 20 years. This is a result of a combination of measures, from switching from high sulphur and solid liquid fuels to low sulphur, such as natural gases. Projections for future decoupling is electric cars could cut oil imports of 40% by 2030, and new biofuels had the potential to contribute to 1/2 of the energy demand in developing countries by 2050. Science is a major contributor to the Australian economy. New developments in renewable technologies and structures have created opportunities for economies to decouple growth from the current greenhouse gas emissions.
The world's population is predicted to increase by up to 1/3, with the economy set to double within the next 15 years alone. This growth is the major driving force for our world's development. As these economic, environmental, and security imperatives converge, advanced resource productivity is quickly rising to the top of the global agenda. The increase in population, income, fossil fuel, mineral, and timber production is putting pressures on natural resources and the environment.
Australia has relatively poor rates of energy and resource productivity, 11th worst and 4th worst, respectively, among OECD nations. If Australia wants to remain competitive in the world's future economy, they need to improve both energy and resource efficiency, boosting the flagging efforts to address Australia's poor productivity performance over the last decade. The Renewable Energy Target (RET) scheme is designed to ensure that 20% of Australia's electricity comes from renewable sources by 2020. The RET scheme is helping to transform our electricity generation mix to cleaner and more diverse resources and supporting growth and employment in the renewable energy sector.
Better resource productivity can help to both improve the environment by reducing the amount of resources that human economic activity requires, as well as diminishing the associated environmental impacts, and to improve resource security and competitiveness. Climate change is no longer a myth. We see its effects every day in the world that surrounds us. In order for us to reprimand the deteriorating climate, solutions in the form of technology and mitigation must be implemented. Biomimicry, whole system design, decoupling, and resource productivity are our best bet for a brighter future.